Hi, everybody. Just wait for the last few people to sit down. Hi, my name's Ian Owens. I'm the Deputy Director at the Natural History Museum, just across the mall there. It's a real pleasure to welcome you to this conference. I've only been here, you can probably hear by my accent, I wasn't born here. I came, there's always one, isn't there, Diane? Always somebody late. Actually, this conference is one of the reasons I came to the Smithsonian. A few years ago, Diane and the team were kind enough to invite me as an outsider to come to this conference. And a lot of people from the Smithsonian could see that it was a place that was really taking Digitization Plus seriously. So it's a real pleasure now to be here as a member of the host team, welcoming you to a session on research. I'm, by origins, a biodiversity researcher. So biodiversity scientists, we are very, very, very data hungry. It's more or less what limits what we can do. And I can't really overemphasize how much the sorts of things we're going to hear about in the next few minutes have changed that science. When I began my PhD, which wasn't very many years ago, the average scale of an ecological study, so I was wanting to do global scale studies. In fact, when I was going through the literature and so on, the average scale of an ecological study, in terms of its size, was a little bit less than a meter squared. So that was the type of data we were playing with. The average number of organisms contained in that study was 1, and over half the time it was a vertebrate, which was fine for me because I studied birds, but even I could understand that's not necessarily a good sampling of biodiversity on Earth. And the average duration of those studies was a little bit less than 3 years, because a lot of it was being done by PhD students and postdocs, and that was the state of the literature at that time. Now that has changed a lot since that time, but I would say now it's on the crazy part of the wave of change. It's changing year by year instead of decade by decade. Sorry, yeah, decade by decade. The reasons for that are multifold, and I'm really glad that we're going to see those different facets today. So some of it is about how fast we can capture data. We're no longer limited to meter squared, single species studies just over a couple of years or so. We have the technology at least, to capture a lot more data. Now it's about prioritizing what we turn that digitization machine on. And you can see a lot of the studies here are basically starting to talk about prioritization in one way or another. So we now have the digital tools, if you like, to amass data. We can also share data, though, and combine data incredibly more effectively. I look back on those early studies I was talking about that I was involved in. Our way of sharing data was to put it on a floppy drive and to send it off around the world. I, in fact, got an email very recently to somebody asking me, I like to think some keen young thing in a university somewhere, asking me for some of my old data, hopefully because they were inspired rather than because they're checking my maths, but you never know. And I realized, wow, to get that data now, I think it's in my mum's house, in my old bedroom, on a floppy drive that I would not have a machine to put it in. And I know that the main thing that's on that drive is actually the operating system for that old computer. Think about how far we've come from that in terms of how much we can potentially make that data available, link it with other data, and make it usable to all sorts of people. That is a revolution in how you do science. Add one more component to that, and that's the availability of algorithms. I look back, if you went back and looked at that paper that I published all those years ago with that floppy drive, I know that the calculations that were done for that paper were done by hand, by myself and a friend. I think we checked it in a piece of software that we thought probably worked, but we weren't quite sure. But we didn't have the algorithms to do anything sophisticated at all. A statistical test that had a couple of factors in it would take us a week to go through the maths. I think you're going to see some things in this session that would take probably longer than a week to calculate by hand. So it's an incredibly exciting time to be a research scientist in any of these fields that are data hungry, that want to share data, and want to really find new ways of exploring patterns that are quicker than a single human mind sitting in an office. So I won't delay you any further from hearing the real content of this session. Got 3 great speakers talking across all the topics I've just mentioned. Let's begin with Doug Boyer. Now, Doug is professor at Duke University in the Department of Evolutionary Anthropology. Doug, though, is equally, and I guess this is characteristic of the field now, Doug is equally well known, at least, for being the creator of a resource that lots of us use. I think he's going to talk about that today and tell us how he got there and what you can do with that sort of software. Over to you, Doug.
All right, thanks for that introduction. And thanks for the invitation to speak. To sort of give you I think the take home of my perspective here is that if we want digitization of museum collections to empower research, we have to also be thinking about integrating museum collections. So not just digitizing the Smithsonian, but integrating its collections with, for instance, the American Museum or the Field Museum in Chicago. The other thing that we need to do is we really need to recruit the help of the research community. And we need to leverage their contributions to mass digitization. And this brings up one of the barriers that we're trying to break down with our project that is otherwise mentioned only implicitly, which is that we have to consider cultural change in the research community around sharing data, as well as these other kinds of barriers that limit access. Oops. So as a researcher, I think museum collections are underutilized and underappreciated. And I think we all appreciate that in current society where there's more and more emphasis on big data and digital technologies, that it's only more difficult to engage researchers and the public in those in the museums. And the primary barrier driving that underuse and underappreciation remains as the distance, the physical one. So as a researcher in Durham, North Carolina, I know I have a limited amount of time and funds to do any given research project, so I'm going to maximize my data collection potential by first visiting the collections that are closest and largest. Only if absolutely necessary will I go to more distant, smaller collections. Now, if that physical barrier wasn't there, this seems to have automatic timing going on it. If that physical barrier wasn't there, I might collect larger data sets and visit smaller museums and spend more time on analysis. So the vision is then that we could break down those barriers by distance and the barriers for the public of not being able to go behind the scenes by creating virtual museums through mass digitization. And that would also allow us to recruit museum objects in digital engagement much more meaningfully, of course, as well as big data analysis. But there are, of course, significant challenges here. The digitization at a collection scale is a major undertaking requiring staff time, expertise, and infrastructure that most museums just don't have. And even if you had the personnel, the workflows, and the infrastructure to do this, we are still looking at a massive decades-long project. The idea of digitizing 155 million specimens is undoubtedly a decades-long project. And we need to maximize the value of that incremental work if it's going to be if we're going to continue to get support from our administrators and from our community to do it. So what collections do we start with, and what modalities do we use? The good news is that there are programs like the Global Biodiversity Information Facility and projects like the integration integrating digitization of biological collections programs at NSF that are getting the ball rolling by creating protocols and funding pools for helping museums to digitize and serve their records. The other good piece of good news is that their research community has been, for the last couple of decades, engaging in a mass decentralized digitization effort for specimen representations. And the other part of the piece of good news there is that they're prioritizing that work based on the value of these specimens for research. The bad news here is that while collection aggregators like the iDigBio program, which have 120 million records right now, can have a lot of records, they're limited in what kinds of data they can accept and from where. Okay, so they can receive data that represent museum collection records and simple kinds of imagery from museums, but they can't receive or describe complex imagery like 3D scans or the underlying data from individual researchers. And that unfortunately means that people like me and Owen have drives full of data that we would like to share and we'd like to integrate, but we don't have a way of doing it effectively. So what's needed is a web-accessible platform, or this is what I would argue, is that we need a web-accessible platform that allows researchers to submit image data on specimens and that then integrates those data with museum-provisioned and maintained, or sort of centralized records, and has some way of incentivizing use. So we developed MorphoSource, launched it as a soft launch in 2013 as an example of what that could look like. It's funded, it's part of the Duke Library Digital Repository, so this is an explicit collaboration with library repositories. It's supported by private and federal funds right now. It's currently a LAMP stack. However, it's under refactor as a library preservation stack, Samvera on Fedora, and we're using IIIF protocols for the viewer that's in development. Our original target community is researchers with 3D or 2D data on vouchered museum specimens that they want to archive. So anything from skeletons to pickled rats to fossils. Any researcher can use it to fulfill data archiving requirements. And speaking of preservation, one thing that we do that a lot of these more generic repositories don't do is that we strictly only accept open access formats, and we have explicit metadata for describing different kinds of imaging modalities. So for instance, volume data like what comes out of CT scanners and MRI, these are displayed as volumes but made up of stacks of 2D files. And we can also describe and preserve mesh files as come out of photogrammetry and other line of sight scanners. So right now, we have 24,000 specimens from 350 museums. If you browse project pages, you'll see something like this, where you see a little specimen thumbnail, a link to see all of the media associated with that specimen, and in most cases, an indicator that the record is museum integrated. That means the specimen record information has been sourced directly from a museum provider. And if you click on it, you can go back to the museum provided record. Integrating with museums actually means that we can serve machine readable data on the media back to the museums, and in an automated way, they can actually push that back out they can get those machine readable data records and push that back out to data aggregators. And so you can go to the Global Biodiversity Information Facility, where there's over 1 billion natural history observations, and find the MorphoSource data that way too. So the 24,000 specimens represent almost 80,000 data sets. That's because a specimen that's a skeleton has 200 bones in it, so you might have 200 data sets with one specimen, and you might image it in multiple ways. This represents 10,000 species right now. There's quite a diversity there, so whatever you're interested in, whatever kind of experiences you want to create with your students or in your research, you can do that. So among animals, we have 5 different phyla represented, and in terms of breakdown, a lot of fish, a lot of reptiles and amphibians, a lot of mammals, then we have invertebrates, birds, plants, and a few dinosaurs. Speaking of the cultural barriers, the use of this site has increased exponentially since we've started, and in fact, a third of the data holdings that I just told you about have been added in just the last year. The source of growth comes from 1,200 contributors. These are essentially people we've vetted as credible data contributors. Mostly they're independent researchers, but we also have formal partnerships with about 18 museums now, where we're working together in an NSF-funded project to populate MorphoSource with representatives of 20,000 genera over the next 2 years, and that'd be about 80% of vertebrate diversity. We also get some data from researchers loading scans from the Smithsonian or the American Museum under the instruction of the department head there as a way of making those scans accessible. Reasons to contribute include collaboration. Researchers can share well-described data with a collaborator across the ocean. They can also use this to fulfill journal and grant data deposition requirements. They can upload a data set, assign a DOI or a permanent unique identifier, and that meets the criteria needed for a permanent citation of those data in a published paper. And then the other reason is to demonstrate use and value. Every time someone downloads a data set, they have to indicate what their use category is. And so a researcher can start to build a profile of use, of data impact in terms of use intent. And we actually have about 1,000 Smithsonian specimens, about 8,000 scans, and we have those data as well, or you can pull them from the data reporting page. If you want to ask me about the details later, we can break it down. So what are they being used for? We have 9,000 users who are downloading data. They're downloading it at an increasing rate. This is what the use rate looks like. This orange line is the number of different users downloading data every quarter. Right now, we're at about 6,000 users per quarter downloading data. And they're using it for publications. And this is arguably one of the most important value propositions for research data. Does it get used in publications? So this is how the citation of MorphoSource has increased in the last few years. We have a total of 400 citations right now in 123 journals by 1,300 authors. Taxonomically, all different kinds of biologists use this: mammals, reptiles and amphibians, invertebrates, fish, dinosaurs, plants, birds. But I wish the bird people would move. All right, so a key question is how to measure the value of hosting specimen representations online. And one way we can think about it is the research impact of each additional specimen. So if we look at these occurrence aggregators, we can look at how many occurrences they have and how many citations they had according to Google Scholar in the last year. And we can use that to calculate an impact factor. And this is really a per mil impact factor, because if you divide 133 by 121 million, it's a really, really small number. But what this shows is that even though these occurrence aggregators are undeniably the foundation of a research-ready virtual museum environment, the incremental value of adding each specimen is quite small. But MorphoSource shows that if you have a rich data set with 3D data, you can greatly increase the impact of those virtual specimens for research. And so in closing, I think that the future vision here is that data aggregators and museums can form, along with platforms for digital specimen representations, can form the core of an extended specimen network. So another example of digital specimen representations is the Macaulay Sound Library, which is vocalizations of birds. These resources can be used to support development of more abstracted and derivative databases, a number of examples already existing. All of these resources need to be machine readable and have interoperable APIs. And in this framework, museum data can be, I think, better appreciated for the unparalleled and irreplaceable resource that it is by both the scholarly community and the public, and no matter where they live. And so with that, thank you.
Thanks very much, Doug. Impressive number of slides as well that you managed to get through there in 10 minutes. And yeah, those sorts of sources are completely changing the way that we do biological research. Okay, a different topic. Now, very pleased to welcome Kayo Denda. Kayo is the librarian for women's gender and sexuality studies at Rutgers University Library. Over to you.
Hello, everyone. Can you all hear me? Yes? Okay. You can see the title of my presentation, and I'd like to explore a little bit about our philosophy, if you will, in approaching this project that I was involved with. And I'll be speaking about two projects with digital components that I participated in partnership with the Department of Women's and Gender Studies and the Institute for Women's Leadership Consortium at Rutgers. I am the liaison librarian for these units. So our approach to these projects was a team-based engagement model based on feminist pedagogy. Our approach is also based on critical works of Brazilian educator Paulo Freire, where the importance of broad experience as a source of knowledge is influenced by the notion of social justice. Both feminist pedagogy and Freire reject hierarchical role between the participants and share the notion that every member has distinct and valuable experiences to share and to learn from. Participation in this project enabled opportunities for every member to offer their unique perspectives to the overall goal of the project and learn from one another. My first example relates to the journal Science, Journal of Women in Culture and Society. Some of you might be familiar with. It's one of the most prestigious academic journals in the field of women's and gender studies. Since its founding in 1975, the journal editorial office changes home every 5 years to refresh intellectual vistas. The Science Journal editorial office came and stayed at Rutgers under the leadership of distinguished Professor Mary Hawksworth for 2 5-year terms. During the course of a decade, the journal editorial office and the libraries collaborated in multiple projects. The most significant collaboration came at the end when we worked together on this 40th anniversary issue of the journal. This is not dynamic, so I cannot show you how this graph works, but basically, with the assistance of Professor Goldstone, Andrew Goldstone, also an English scholar at Rutgers, this topic modeling identified and divided the archives of the corpus of the journal text into 70 topics. So each line really represents a topic, and it traced how it evolved over time in 40 years. This angular stream graph, that's the name of the graph, captures variations of feminist intellectual labor in knowledge production through time and space. The process that led to the creation of this special issue was conceived as a collaborative research led by 2 graduate students with contributions from digital humanities scholars, librarians, and undergraduate interns in addition to the members of the editorial office. In addition to topic modeling, the special edition includes other sections. This is a co-citation network that visually represents the connections and networks of scholars and their scholarly works. This is a curated special content, identifies significant topics such as intersectionalities here, introduced by the journal. The analysis of the journal cover arts, for example, over the decades capture an evolution of visual aesthetics and sensibility. The editorial comment section include reflections from different experts commenting on singular aspect of the journal from their own perspectives. This diverse range of collaborators not only embodies feminist pedagogy, but also reveals a broad vision and commitment by the journal editor to an interdisciplinary journal with broad representation. From the libraries and archives perspective, the participation in this project legitimized libraries and archives as players with central roles in scholarship published by Science Journal. So my second example relates to this documentary titled From the Boarding House to the Boardroom, 200 Years of Women at Rutgers. This is available on YouTube. And this documentary was created by June Cross, an award-winning filmmaker, and produced by Rutgers Institute for Women's Leadership Consortium. And as the title indicates, it was created for the celebration of the Rutgers 250th anniversary in 2016. Rutgers University, founded in 1766, initially educated men to serve in the Dutch Reformed Church. During this long history, women gained access to the university as students only in 1918 with the establishment of the New Jersey College for Women, now Douglas Residential College. Yet, from inception, women have played vital but invisible and unofficial roles in the university. In order to tackle this enormous task of discovering resources for the documentary in a very short time, and I think it was less than 1 year, the Women's and Gender Studies Department devised a creative way to involve students in research uncovering primary source material. Thus, the directed research seminar, From Exclusion to Inclusion, 250 Years of Women at Rutgers was born, in which I served as a co-instructor. We literally unleashed graduate and undergraduate students in the archives to pursue investigations of their own relevant to the history of women at Rutgers. I'd like to share some examples unveiled. This is a wedding dress by Dina Wemberg Hardenberg, who was who was a wife of the first president at Rutgers. This is a poem titled College Widow, and College Widow seems to have been an amorous character. And this was published in 1904 Rutgers College Yearbook. And there is a flyer of the movie with the same title. This is a newsletter from Student Homophile League, and Rutgers was one of the first universities to establish a student organization, a gay student organization in the nation in 1969, not long after Stonewall riots. These are abortion ads from 1971 Douglas College student newspaper, and apologies for the poor quality of the images, and titles and pamphlets about Title IX for the student body. So in addition to these primary source material that the students discovered, June Cross interviewed 13 individuals to collect information for the documentary From the Boarding House to the Boardroom. The interview subject included current and former faculty members, alumni, and administrators, and its content was extremely rich with institutional history. However, the 30-minute final documentary included only small clips from the interviews, and in the case of some individuals, their narratives did not make to the final cut. We really wanted to preserve this unique material, but to be included in our institutional repository, the interviews needed metadata. We have the good fortune to have the Library and Information Science Department of the School of Communication and Information on the same campus. We identified 2 graduate students enrolled in the course on metadata to assist in metadata creation. The students were eager and delighted to put the theory from the classroom into practice. With the final touches from the metadata librarian, the portal Women, Education, and Leadership at Rutgers was finally launched in spring 2019. And this is actually the first section, and we would like to increase the content of this because undergraduate students created short clips inspired by the stories of these narrative interviews. So we are hoping to upload these short clips of maybe 3 to 5 minutes of student works to sort of have a different kind of work that is student-generated, almost in response to these narratives by the people in the interviews. But that is a project that still needs to be concluded. So designed and structured intentionally and at the same time taking serendipity seriously, collaborations such as these examples with academic units, with diverse participants, present vital opportunities for acquisition of new knowledge and active learning. These collaborations also present a golden opportunity for the libraries to showcase our unique collections and insert elements central to our mission, such as discussion on intellectual property and the significance of metadata in access and discoverability of digital resources. So as a librarian, I'm looking forward and thinking deeply in terms of what is a framework. Libraries and homework too, right? Libraries and archives must aspire for greater engagement in feminist and digital humanities scholarship. In addition to collecting and storing, a basis of library organization, collaboration and engagement with on- and off-campus partners present great potential for exploration. And I'd like to end by mentioning that the Learning Lab platform created by the Smithsonian Center for Learning and Digital Access offer great potential. And the facilitator of the previous panel, Stephanie Norby, talked about their platform. And I was very fortunate this summer to receive a fellowship in museum practice from the center. And I had the opportunity to familiarize myself with the Learning Lab. I'm convinced that the Learning Lab had great potential for feminist digital explorations, but this is a topic for another discussion. Thank you.
Thanks, Kayo. Looks like you're already setting up the first question there as well on the lab. Okay, the last speaker in this session is Peter Leonard. Peter is from Yale University, where he's the founding director of the Digital Humanities Lab. Over to you, Peter.
Terrific. Well, thanks so much for the opportunity to come and speak today. I wanted to talk a little bit about something we heard a little earlier. We're going to hear again tomorrow about. We've already heard artificial intelligence and machine learning mentioned by LaToya in her talk, which I thought was just an excellent overview of some of the promises and the potential problems with applying these new forms of math and applied machine learning with the archive. I know that Dr. Noble's talk tomorrow will also engage with some of the challenges around algorithms and cultural heritage and lived experience. Today, I just want to present about 8 slides and about 30,000 images connected with the problem of, I'm not joking, of neural networks and digitized image research. And I want to start by asking, has anybody ever heard of the Meserve-Kuhnhart collection? Anybody in this room, raise your hand if you've heard of that. The reason I chose this is because it's split between my institution, Yale, and the National Portrait Gallery here as part of the Smithsonian. You guys have the good stuff. You have the 5,000 Matthew Brady glass plate negatives. That's the high-value stuff. Our Beinecke Rare Book and Manuscript Library has like 60 to 70,000 prints and other ephemera. And because the collection, which was put together by this private family over the course of almost a century, is split between the two institutions, we began by thinking about, could we reunite this collection and think about this relationship between prints and negatives using sort of forms of machine vision. And I think it's much better for me just to show you this than to tell you about it. So what I want to do is I want to show you something we built which lets you browse the Meserve-Kuhnhart collection by the Matthew Brady negatives. So these are all things I've downloaded from the National Portrait Gallery. They're beautiful prints, but I don't want you to admire them so much as to observe what happens when I move my mouse over a particular guy in the top left. And so as I'm doing this, I'm moving my mouse, and this is this gentleman. You can see what's happening at the top above that. As I move my mouse, I'm getting other images from the Meserve-Kuhnhart collection. Maybe I'll just take this example here. This is a picture. I'm going to select 1, 2, 3. Right now I'm using my own eyes, not machine vision, to make selections from a set of related images or visually similar images. So I'm using my own judgment to say that these all look like prints or reproductions or in some way reprints of the original Matthew Brady negative, and then I can sort of look at the actual metadata. Some of these images are from NPG, some of them are from Beinecke. Fremont's name is spelled with and without an accent. All of this information is variable. But your own eyes can tell you that this system has found the prints in the collection. And so you could ask, well, how do we do this? One way we don't do this is we don't rely on any metadata. We don't rely on any description or provenance in this particular application. What we instead rely on are convolutional neural networks. So it's probably time a little bit to talk about that. Convolutional neural networks are often used in order to describe the world around us with contemporary terms like cat, dog, skateboard, bagel, banana. That makes them inappropriate for use in the 19th century. There just aren't that many pictures of bagels or skateboards in the Meserve-Kuhnhart collection. But the ability to make that final decision, this is a cat, this is a dog, is predicated on a whole series of steps of machine vision that in some way mirror our own visual system in our own human brain. And the way to think about the power of these networks is that we can take off the last layer, the final layer which tries to classify something as a cat or a dog. We can step backwards into the artificial vision system, into the penultimate layer, into the semi-final layer of this network, which isn't concerned about cat versus dog, but is concerned about 2048 ways of seeing that help you distinguish a cat from a dog. And this essentially solves the featurization problem for you. It gives you a very robust way of seeing. In fact, it gives you 2048 ways of seeing. This is a really high dimensional space, 2048 dimensions. What we want to do is we want to go to this pretend space, so think of X, and then think of Y, and then think of Z, and then think of 2045 other imaginary directions. We're going to perform an approximate nearest neighbor search in this high dimensional space, and it's going to get us the resulting images, which are similar to a particular Matthew Brady print. Now, we did this project, and it was really cool, but what we found was that we weren't just finding simple prints from the Matthew Brady collection. What we were really discovering, and this slide is perhaps the best example of it, is we were really uncovering pictorial tropes or conventions of portraiture in this 19th century collection, which sort of starts in the 1860s and stops in the 1890s. So you're thinking about the American Civil War, the Gilded Age, that period of time. In this screenshot, which I just took a picture of because it was so fun, I've moved my mouse over Johnny Giles on the bottom of the screen at the center. And then what's appeared at the top are all the images that are visually similar, closest to this one particular image in 2048 dimensions of seeing. Remember, it's impossible to describe those dimensions, but we may suggest that there's one of these vectors, one of these tensors, which is responding to the diagonality of the human arm or to the skin texture. It's hard to say. One thing you'll notice about these results at the top of my screen is that one of the pugilists is pointing the wrong way, so to speak. So this isn't just looking for simple relationships, it's actually picking up on something more complex. And the other thing you'll notice is that, to my eyes at least, John Banks, second from the right, appears to my eyes to be African American. So we might intuit that this network is more sensitive to line than to tone. There are ways of interrogating the network to find out exactly what is being triggered in order to pull up these results. But what you've got is essentially a virtual subject category of the boxer, which, especially in uncatalogued collections, is kind of exciting to think about. I want to then move on from doing a simple project about taking a glass plate negative and finding all of the prints that ended up in New Haven or in other museums, and talk about the other latent possibilities of this space. So I told you before we had a 2048 dimensional space. It's pointless to try to explain what all those directions are. They're just different mechanical ways of seeing, different sort of versions of computational gaze. But in doing a comparison like this by bringing up prints or visually similar images, I'm really leaving unexploited the power of this 2048 dimensional space. All I'm doing is showing you the images that are closest around this one particular boxer, or the images closest to the military man with a sword. And so what we thought about doing was more fully trying to use that space that we've built with a pre-trained convolutional neural network. And what we're going to do is we're going to show you a demonstration of that. And in order to do this, I'm going to turn back to a museum in New Haven, the Yale Center for British Art, which, like other museums here in DC, has put an enormous amount of its images online for free. I've downloaded those. I've thrown 31,000 images on the floor from the Yale Center for British Art. Please don't tell them I did this. But if I'd really thrown these images on the floor, they wouldn't have landed in any way which suggested any kind of visual clustering. In particular, they wouldn't have landed in such a way that all of these caricatures of well-dressed dandies ended up at the bottom left of this screen. So again, that's the bottom left. Let's zoom out and see the entire constellation. There are other clusters that are kind of interesting. I know we may have some naturalists in the room, and so one of the things I like to point out is that in the very middle of the screen here, we have all of these botanical illustrations. And I don't know if there's a category in the Yale Center for British Art for botanical illustrations, but there certainly is in this visualization. There's a kind of cluster of those. We can also go to the zoo, so we can see all of the images of the English countryside, people riding fox hunting horses, I don't know, there's like a camel in here. There's all sorts of other things that are kind of interesting, like political cartoons. So what are we doing? How do we build this visualization? Well, we took the same 2048 dimensional space that was helping us find visual similarity before. And what we did is we did a practice of dimensionality reduction in order to show all of these images in a two-dimensional screen, because although I asked, Diane was unable to get me a 2048 dimensional screen for this talk. So dimensionality reduction, the way to think about that is you've got a beautiful three-dimensional flower that you're trying to take back after a voyage of discovery or conquest. And you know this flower will not survive if you try to just bring it back. It'll rot into nothingness. You've got to press that flower between the leaves of a book. You've got to sacrifice the third dimension, squish it flat in order to preserve it, to put it back on the ship, go back to where you came from. The naive way to do that would be to crush the flowers so that the bird of paradise no longer looks like this very interesting flower. The better way to do it would be to lean that bird of paradise flat and lose the width, but preserve the shape of the beak, the shape of the tongue. And that's using your human intuition to do dimensionality reduction. Here we've used a particular form of mathematical manifolds in order to ensure that we preserve both global shape as well as local clustering. One of the funny things about the Yale Center for British Art is that they correctly consider frames to be works of art in their own, and so you'll see these are all my frames here, but they're in a neighborhood or surrounded by other frames in which that really threaten to dwarf the actual visual content of the painting. So this is kind of like Frameville. I've had one of my colleagues work on this. She downloaded a whole bunch of images from the Library of Congress. This is like thousands of images from the 1920s. You can see we have this kind of gymnastic or pugilist aspect there too. She's labeled her categories on the far left: baseball, billiards, pianos, all sorts of interesting images from the 1920s. We write open source software that lets anybody do the kind of work I've just shown you with a Yale British Art or with this Library of Congress information. It's called Pixplot. It's available on GitHub. It produces this WebGL-based website that you can have a very performant experience moving through 30,000 images. And future versions of the software will let you as a curator or a digitization manager actually drag a lasso in what you're seeing and select all those horses and push them into a separate bucket for you to work with later. I'd just like to acknowledge the team at the Digital Humanities Lab who've helped us put this software together. Thanks very much.
Thanks, Peter. Great talk. It's off the screen now, but if those of you that haven't visited Peter's lab in Yale, it's probably maybe the most gorgeous lab I've ever been to, in the middle of that Yale library there. Okay, we've got a few minutes for questions, so shall we, we'll move the chairs around on the stage. If people start thinking of what they would like to ask, we'll start a conversation with the group, but then I'll throw it out to you guys pretty soon. We changed microphones yet? Yeah. Can you hear that? Sure it's working. Okay, Peter, there we go. Peter, let's start with you since you're fresh in everyone's mind. So incredibly quick, clever analysis of huge number of objects. How many objects did you say? There was 30? 31,000 images from the Yale Center for British Art. Okay, so a huge array of art. So given who's in the audience here, is there still a role for curators, given your algorithms?
Right. Is it which for curators? Yeah. That's a great question. We actually, so I should say that, of course, the Yale Center for British Art has one of the best described, best curated collections on my campus. There's so many hardworking professionals. They're pioneers in linked open data. I'm sure people in the room have worked with Emmanuel and others. So there's something kind of weird about taking such expertly described images and, as I said, throwing them on the floor. We sort of wrote some of this software because we thought that there might be collections that weren't as well described as the Yale Center for British Art's images in which that we didn't know very much about their provenance, we didn't know very much about how they should be cataloged, or there might be situations in which we were trying to introduce students to some of the problems in cataloging and categorization and description. And so whether you're working with a collection which you think you know the right way to describe it, to characterize it, or you're working with a newly acquired collection, which maybe one in which it is well described, but it was described in the 1870s, and you're not confident that the sort of critical archival vocabulary of the post-Civil War era is the right language to use for 2019. Putting your expert human judgment in conversation with the sort of limited ways an algorithm can see can sort of spur you to think and to always let your human judgment be the final say, but to have some engagement with forms of machine vision in the cultural heritage sector.
Can I ask a question? So it's absolutely fascinating, I think, a beautiful work. But do you, I think you just mentioned that it is a way of categorize images for material that the description is either missing or lacking, or maybe it's been, it's historically, it's historical but not in terms of how we understand the terms now. So do you see this kind of, this happens to be an example in arts, but do you see, I was thinking of your collection of skeleton and such, do you think that's applicable sort of across disciplines?
Sorry, so the question is what is applicable?
The technique that was used to aggregate.
Oh, yeah, no, that's a fascinating question, and I think it definitely is applicable in different realms. What I wasn't able to talk about is some of the informatic work that I do using geometry of bones to kind of understand clustering of shapes in a way that represents biodiversity. And we're using, we're taking manifold-based approaches and trying to understand sort of the shape space of anatomical form in that same way. I think what would be really amazing is to sort of combined approaches where you're looking not only at sort of color information, vector information of a texture, but also the geometry of a surface, and combining those sources of information for providing even richer representations that might have some meaning about, at least in the biological realm, the evolutionary patterns and the processes underlying them. But yeah.
Yeah, I think I know Rebecca and Alex and others at the Smithsonian, the data science lab, have been doing, as we heard this morning from Daron, some of this great, classification with just as good as human accuracy on some of these things. One of the things, and this may come up tomorrow in Dr. Noble's talk, is, in the hard sciences, or if you're a taxonomist, or if you've got a sort of genre and subspecies, you can judge accuracy of labels of categorizations. In my field, we're less confident about saying, great, we've put this person in a bucket, he is a boxer and this woman is an opera singer. That may be the convention or the genre of portraiture into which they were captured in 1860, but we're less, at least me personally, I'm less excited about applying labels to people automatically. And so I think that's a really interesting question in the two cultures, is we can measure efficacy of neural networks in plant morphology to a certain degree if we believe in the Linnaean classification. It's more difficult when we're dealing with cultural heritage, with images of humans and human activity. Not to say it can't be done. We have Library of Congress subject headings. I'm sure those are perfect, can never be improved. But I think that you have to think some of those things through. So.
Yeah, I think, again, I guess we naturally think about it from a biological perspective. Some of the work that I've been involved in the past, actually sometimes after 5 years or so of classifying objects in a way that you are testing hypotheses, actually you end up realizing there's something profoundly wrong with what you're trying to do. And often I end up realizing that's because I'm a particular sort of monkey looking at these birds. And I'm very interested. I have a particular set of particular apparatus for getting that information, and I'm very tuned to particular patterns. And gradually you realize, even with other vertebrates and so on, whose sensory systems aren't that different, you realize, I'm probably looking at this completely the wrong way. So your analogy there of throwing those pictures on the floor, for some of the data that I've worked with, after 5 years, that's what I most profoundly want to do. Throw it on the floor, initially in disgust, but secondly say, well, what patterns would emerge if we're not going in as a kind of fruit-seeking monkey? How different would that look? Let's change the topic a little bit to trying to get different people to use this data, because lots of the things that we're trying to do, we're analyzing the data in different ways, we're bringing it together. We're also trying to expand who has access to this data, different fields, and I guess I also get the impression that we're interested in democratizing the data a little bit. I mean, Doug, you started off saying that, you know, even for you, it's limited where you can get to around the world in the most efficient way. Kayo, some of your work is trying to get different people to use these sorts of resources, isn't it? Can you talk about the role that technology can potentially play in diversifying access to collections?
Well, the project that I think definitely the technology inserts a new dimension, not only for the users, certainly for the creators, but I think, I'm sure it's a case for different projects, but I think the intentionality of the project is something that it has to be built from the very beginning. So whether it's a high school project with the students or with undergraduate students at Rutgers or a community of scholars, what is exactly that the project is aiming to do? So in the case of the journal, for example, the intent of the editor was really to open up readership and diversify the range of contributors to the journal. And the way to do that, it was believed that diversifying the range of authors, the topics of this anniversary issue would actually bring more readers and there's more subscription. And I think to a large degree that was accomplished. That's why she was actually invited to stay for a 2-year term as an editor. So it was a lot of work, but I think from where I come from, I'm a liaison librarian. I'm certainly not a very technologically versed individual, but with the resources that we have, I think we would like to, the intent for us comes from the really goal of the course, of the project that the faculty are interested in. So that kind of aligns our efforts to either use technology or to invite somebody who has technology, like Professor Andrew Goldstone, or kind of see other possibilities. And for me, the fellowship was very exciting because for one reason or another, I had never been very versed in the collections of Smithsonian for my own work. It's a big, I think I should be ashamed of it, right? In front of so many Smithsonian people. But the fact is, I think the library community in general thinks a lot about Library of Congress, but we have not really been very attuned. And I think learning about the capabilities of the Learning Lab, for example, the Learning Lab comes with 2 million plus objects from Smithsonian. So that's in itself is a tremendous asset that I can bring to my constituents. So I see that an enormous learning process, and again, I would be very customized in that specific class or specific project, but I think it has a tremendous potential. And I was glad also to hear that the Learning Lab is interested in including student works, because I think the high school teacher, the panelist before mentioned, I think it really includes a new dimension. It's very different from your project or your project, but I think in institutions like ours, that we have a group of undergraduate students that will be graduating 4 years, we do want to honor their creativity, their accomplishments, and in some ways we want them to be ready for this digital ecosystem, and we want them to learn how to express themselves and how to understand digital assets. I think the panelists before talked a lot about intellectual property, the limits or the possibilities, and which is all a different ballgame for all of us, right? And I think it enables us to create an environment in which we can discuss these things more seriously.
Yeah, it struck me as well when you started talking about the Learning Lab right at the end there, that one way to try and open up access is to add better search algorithms, add better tags, and so on. Another way of doing it is to try to get that material, that content, onto platforms where people are already. Several people have mentioned some of the really big platforms, Google, YouTube, and those sorts of things, but also things like the Learning Lab. There's already a crowd there, if you like, that are using data in a particular way. So to get some of these collections on there, usable in that way, could potentially get to a new demographic.
Being useful, because I think the libraries and the museums have a common mission, which is to be the collections to be used by our user community. And whatever tools that we might have that enables that is a welcome addition to our environment.
Sure, yeah. So in terms of providing platforms where sort of new demographics can engage with materials that they couldn't access before, we've tried to sort of set up the potential for that on MorphoSource. One of our, our kind of the first level goal was to give researchers a place to publish data. The second level goal was to make it, as easy to be able to distill that very technical data into an access modality that's easy for the public, and for educators to understand. And I think we've had some decent success with that. I would say about half of our downloads are actually for non-research use, and there are sort of growing numbers of education-focused collections on MorphoSource. And so I think that, focusing on platforms or venues where you can give researchers a way to provision their data in a format that a broader demographic can appreciate it is really valuable.
I have a question.
Yeah.
Sorry, I have many questions. So, for example, Rutgers is a state university, and one of the missions of the university, at least in paper, is actually to make bridges with the community where we are situated. And I was wondering if universities like Duke or Yale also, your projects, which are very specialized and very high quality, is there any room or is there any preoccupation from you to sort of make it more accessible to a broader community? This is just a curiosity question.
Yeah, I think so. Yeah, so in terms of making it more accessible to the broader local community, Duke has partnerships with a number of high schools, including the Duke School for Science and Math. And we're always looking for opportunities to bring students in and get them involved in that data creation process, and to also understand sort of the both the technical in terms of the technology, but also the technical in terms of the underlying biological information about the work that we do. It's something that I would like to emphasize more, but we've also tried to create a number of sort of what we call K through 12 workshops. We've hosted one at Penn State and participated one at the University of Florida, where we try to get teachers understanding and using and thinking about how they might develop lesson plans to communicate scientific ideas to their classes.
Oh, time?
Want to open it up? Ken's in charge. Okay. I know better than to disobey Ken. Let's open it up then to the broader audience. We've got some questions. We've got a question back on the left there, a couple.
This is for Peter. I'm Tom Blake from the Boston Public Library. I was interested in your PICS plot, and you mentioned you're not doing anything with the metadata, or are you? And if you're not, do you see this as something that can, the more images you get put into your machine, so to speak, do you think that can help if we are using those perfect Library of Congress subject headings, could we get those automatically applied someday?
Yeah, well, I think there's two. So we do have an experimental branch on GitHub. We have the ability to take a metadata facet, so a mutually exclusive thing. It's either painting or sculpture. It's either bought by Paul Mellon or J. Paul Getty, whatever, as a way to modify the visualization. Right now, we just turn parts of the cloud on or off. So you could say everything, you know, by this artist, everything from that artist, and you can see how the cloud changes or that constellation changes. That's a way of working with well-described collections, because you can say, oh, this collector really liked horses, because when I take away their name, all the horses disappear. The other thing would then be, what can I do with the clusters? And what I showed very briefly was somebody drawing a lasso around all the horses. And what we want to do is to, once you've done that, and that's you who gets to do that. You say, I select all these horses, and I'm going to shift select the camel that crept in, because although it looks like a horse, it's not a horse. Take out the zebra. And then you have this subset of like 20 pictures. So what do you want to do with those? Well, we could copy their unique IDs and permalinks to the clipboard. We could download a CSV. We could give you the IIIF manifest to use in a tool like Mirador. If we had an authentication system, we could actually send a tag back to your museum system. I'm going to label these all horse or something like that. So we definitely see this as being, in a future version, a kind of fun curation tool. And I use a kind of lowercase c curation because, to turn to your question, wouldn't it be great if you had 8th graders and you could show them all 30,000 pictures from one of our museums and say, you should create subsets that are meaningful to you. You should select parts that you like, and then we'll let you download them and put them on your hard drive.
Thank you. Yeah, I had a question for Doug. I enjoyed your presentation, but I wanted to ask you about sustainability. You know, normally a scientist gets a grant from the NSF, you do your research, you publish a paper, and you're kind of done. But of course, your project, MorphoSource, is really a platform, and thousands of people have come to depend on it every year. And long after your grant runs out, you're going to be, you know, updating the UI, adding new data, et cetera, et cetera. So how do you address sustainability of the project long term, and what role does Duke Libraries play in helping you maintain it?
Right, that's a great question. The answer to it is that it's an ongoing process. I think there are a couple of things. The call for data sustainability, I think, is one that's being heard increasingly loudly with the funding agencies, and I think there are going to be more opportunities in the future, and more of a, you know, I'm hopeful here, but more of a sense of responsibility from the funding agencies that this is something that has to be considered. The other part of it, though, is that from institutions, where the researchers reside, where the data are coming out of, there's more and more of a mandate and mechanisms for sustaining data. So what we found and what we've started to try to do is build partnerships with external institutions to essentially collaboratively manage the storage of those data, as well as the documentation of it. Duke Digital Library has a commitment to maintaining this as a project for the long term. We're still looking into, you know, how we'll manage the long-term funding of staff positions and that sort of thing. But I think there are a lot of opportunities and a lot of ideas out there. So I think the future is bright in that regard.
I'm afraid that's all the time we have questions for. We're running a little bit late, so if you could be back here at 3:55 for the closing keynote. Thank you.